Thank you very much. I'm also very honored to be invited to talk about our project in World Bio-Innovation Forum. So the talk will be a brief overview of our project, which started last year and still going on. And regarding a negative pressure word construction system, which is called KARE MCM, representing KAIST actions for respiratory epidemic and mobile clinic module. My name is Tek-Jin Nam, as introduced, and I'm working at the Department of Industrial Design at KAIST. Our department started as a small department teaching and doing research in industrial design with a science and technology base about 35 years ago. And gradually, the technology has become really digitalized, and their information technology has been embedded. So we became more towards to human-centered design or interaction design, UI, UX design. Often these days it's being called in often the smartphone industries or some other IT industries. But recently, design has expanded, taking a big roles in probleming social issues. So we are now really interested in design-driven innovation, including social innovation or other bigger societal problems. This project is a part of KAIST antiviral mobile clinic module project, which is a big kind of initiative started last year, where the COVID pandemic started. So the KAIST actually proposed to the government that we can do something about this pandemic situation. And Professor Che was leading this big project and then initiated. And as a head of department at that time, industrial design department, I was trying to help visualizing what we want to do in a situation where we don't know exactly what we're going to do. So this is the diagram that I helped to visualize what we plan to do at that time, and with protection modules and diagnosis model, and then hospital service and treatment module. So this and also this kind of sparked discussion in a newspaper like this, and then gradually it became an actual funded project from the government. It's a big initiative at the KAIST. So a lot of ideas, interesting ideas proposed, but one of the ideas that we thought that is essential is about hospital service, actually. So not only the actual vaccine or some other very specialized technology, I thought that the providing how to treat these the patients is also very important. So I was involved in having kind of planning this subset of this part. And then what I started first was thinking about branding and what we want to do. I think this is a typical starting point of design experts to tackle this kind of big projects. And then in a coordinated manner, we wanted to succeed in a big kind of initiatives driven by KAIST. So, but actually this was the starting point that I was involved in this project. But in some point, I was interested in the big problems at that time. Is early March last year. There was a big shortage of negative pressure isolation beds for especially critically ill patients during the pandemic. At that point, the Korea was managing quite well. We had a really big crisis at the first in Daegu because we are the second kind of, and Italy and Korea was the biggest kind of problem when early COVID started. But gradually, we launched a system called the Residential Treatment Center, which we kind of quarantined the patients in a specific kind of area, which is usually used for kind of training purposes and so on. So that was fine. But what we thought that the most critical part was treating critically ill patients. So we saw these needs, and then we focus more on this negative pressure isolation beds. So in the beginning, because I was not really the domain expert, I started to kind of learn this area and how to build more efficiently in these sort of facilities. And but I found that the negative pressure isolation rooms is not very complicated system. It's basically, it is a space that air compression allows air in and air out system, so that you always keep this certain area, which is usually the patients live in a negative pressure space. And then you have to keep empty room so that the air doesn't come out directly, so that make a safe divide between the areas. And the important thing here is management of infected air, and water and other waste. But at the same time, there are medical activities going on, so it has to support. And of course, the quarantine. Often we have to consider air control between this space, so that we need to have this interlocking automatic door system so that the air is not directly comes out. So this negative pressure isolation bed as its own is not really complicated. But if it goes to the ward system, where typically you see in a hospital, it becomes a bit complicated, because if you have a multiple patients room, and then there are nurse station and medical staff to go in and out, then every time go in and out, there are waste, the infected waste, how to treat. And there has to be some consideration should be given in terms of the path of the medical staff and patients that has to be divided in case very serious infectious disease happens. So when we think about isolation bed, it's rather simple, but if we want to compose it as a more like a medical space, it's quite complicated. So far, these systems has been treated in a way that is more architectural solutions. So for example, this was a hospital that was built in China last year. Within 10 days, they made 1,000 hospital beds for the COVID patients, and using modular architecture system. So they built this large complex hospital within very short period of time. Often they use the gym and just kind of use just to put the beds here, so all the patients in a treat in the same space. Also, the MIT also introduced this something called the Cura open source container-based quarantine system. But usually all these and also tenting are usually in use in the military. But the problem is they mostly focus on quarantine purpose. So it's very difficult to consider when I say there's a layout and coordinated path for the actually medical activities. And also very difficult to apply to diverse medical contexts. And there are different needs in different phases of outbreak. And also some ideas that remain as very concept level, proposal level. So we came up with this KARE MCM and then proposed this idea. So, but one of the things that we considered in the design phase was, of course, there has to be the function, cost, efficiency, very engineering requirements has to be met. At the same time, we thought that the usability and emotional satisfaction is very important in design criteria and also in originality. So basically the purpose of design is to balance all these conflicting requirements, so that the whole system has to be coordinated, the balancing all these requirements. So here is the concept video that we presented. So that explains a lot that we built.
In the sudden infectious disease crisis like COVID-19, it is critical to supply negative pressure isolation rooms at the appropriate time for patients and medical staff. KARE MCM is a mobile expandable negative pressure ward equipped with advanced medical facilities. With its rapid installation, it can supply functional and economical medical facility. It also provides ease of use and emotional satisfaction to medical staff and patients. The main components of KARE MCM are frame, functional panel, and air tent. The most important component is the negative pressure frame. It circulates air through positive and negative pressure pumps inside. It allows individual adjustment of the air pressure in spaces on both sides. Functional panels are wall components that provide a variety of functions. The glove and pass box panel allows medical staff to deliver objects or perform simple treatments to patients without wearing protective clothing. Medical facility panels are equipped with medical gas and device connection terminals. Other functional panels include the transparent window and toilet. The last component is the air tent. The inflated tent is harnessed by the frames and functional panels assembled in the square holes. The connection bar increases the stability of the assembly. It also works as indirect light. The user can freely adjust the color temperature and brightness of the light. KARE MCM can be used as a medical facility for various purposes. It can be assembled for negative pressure ward for severely ill patients, temporary isolation bed in the emergency room, screening clinic, and so on. KARE MCM takes 15 minutes to install a basic unit consisting of an anteroom and a patient room. It can reduce the cost about 80% compared to renovation of an existing hospital building. KARE MCM is easy to install, store, and transport. When compressed, it can reduce the volume by a tenth. The entire ward can be transported by air. Are you searching for an easy, rapid, and economical solution to safely treat patients in the infectious disease crisis? It's KARE MCM.
So the basic idea is, as I explained, the basic units is the anteroom and the patient's room. There is something called a negative pressure frame. And by assembling these frame and also the wall component, which is called panel, we can quickly compose this one building unit, the one hospital room unit. And this is the actual, we simulated the actual air flow in the room so that it comes in from the outside, and then from to the ceiling, and then goes down and then suck into the sidebar and then goes out. So initially we tested this fluid dynamic simulation for whether it works okay. And this is the design mockup that we first built, so that how does it feel as a medical treatment space. So as explained in the video, because we use the two sides, the negative pressure or a positive pressure difference, so that we had these control units, and two sides there are pumps, and also we had this air pump to maintain the appropriate pressure in an air tent. So all these components are within one component, so that without many construction, it allows to make this system mobile and easily assembled. So if I look at the components, there are air tent units and also the frames. There are negative pressure frame as well as this door frame, so that it can be connected through the communication, so that we can easily set the interconnecting interactions and so on. So there are toilet units and also medical units and so on. So these assembling these components, we can build many variations. So at the same time, we had this inside light bar, so that it gives a stability, also the emotional lighting in the room. Well, one of the things that we kind of cared in the beginning was how air flows. So at the top, there are air holes, so that depending on what type, which pattern of the air hole, we found that there are some more efficient air control and flow. So firstly, we had even air holes in the ceiling, but then later we had these refined air patterns, so that we can see that the performance has been increased in this way. So the design process that we did, usually we call open double diamond design process, so that we have this kind of 4 discover, define, develop, and deliver phase. So we think about many different alternatives and then choose one and go into the detailed design and implement. But this project was much more agile. So we actually started last year, August. And then there was a big time pressure last year. We had to deliver some meaningful outcome at the end of December. So we really kind of go into all these pace in parallel. So this is the early sketches that we collected from nurse, so that what the nurse wants in the space. And then we translate it into actual prototype in space in 5 months. So we talked a lot with medical staff and the nurses and also the director. This medical doctor, he was very passionate. And then I probably say that this kind of user involvement in the design process is very essential and very critical. Otherwise, I mean, sometimes we just make the technology can produce. We had 2 major workshops during the phase. And at the same time, we made this first functional prototype just about 3 months later. And having this system, we see the feasibility of this space and also the construction method and so on. And then later at December, we actually built the site in Seoul. So this is showing how this site was built. We had 2 sites, one in KAIST and one in Seoul, in hospital. So to build this site, in addition to the main components, we had to design additional parts such as the big tent unit to make this outside parking lot to indoor space. So we also designed this experimented new air beam tent as a side part of the project. This is assembled interior when it was built. We replicated or kind of referenced the negative pressure ward in KCCH, which is the hospital that we built. They had already 4-bed ward, for critically ill patients. And we kind of simulated how the patients will be treated inside of the space. So we also focused on the usability of the system. So because this is a new kind of system, so we redesigned all these digital user interface and all the monitoring system and control system. In addition, we thought that it is necessary to kind of simulate the plan layout of the system beforehand. So some sites have a different layout, different kind of a space available, so that we made this layout software so that we can quickly assemble these components and how it fits. This was shown to public in early January this year. And at that time, we had this situation that the hospital bed was really almost run out in Seoul. So there is only 3 available hospital beds for critical ill patients available. So we were exposed quite widely in Korea and also in international media. So that actually triggered really fast patent issuing and also the technology transfer to the company that we work with for the early prototype development. And also we got the kind of certificate from the government as an innovative product. Another thing that we are proud of is that this also was, we had a lot of very prestigious design awards, all 3 most prestigious design awards, especially we got 2 Best of the Best Design Awards from Red Dot in product design and also user interface parts. So after that, another big task was actually see if whether this is feasible in real clinical usage. So from the first system that we built, we actually go through all the process of get approval or whether it is possible to use this space as a medical purpose, which was built as a more like a demonstration system. And fortunately, we got past all these phases. And we had 2 COVID patients kind of hospitalized and successfully treated it in space. One of the feedback that the medical staff was responded was that they use this kind of glass wall and on this kind of glove box and pass box was very efficient because they don't have to wear protection clothes every time, which is usually in the building they have to always wear, and then when they come out they had to kind of put it in a infected waste. We also implemented this into vaccination center in Jeonju. So there's a waiting bed. So still it is being used. Another thing that we originally we planned was this is very multi-purpose, so that it is possible to use this unit indoor, so that maybe we can quickly increase the number of beds in emergency department of the hospital or ICU, or transforming normal patient's room to negative pressure beds. So this is a actual case that we built in Gonyang Hospital in Daejeon. So they are still using it, and then there are every day about 5 patients are using this space. In this case, they're not all the patients are COVID, but when they are suspicious, they go in here and then treat. So we are very happy that they are using successfully. And last big experiments, or more like clinical uses test, was done last September together with Gyeonggi-do this year. So one of the early idea was that when we have a situation like a Daegu or Italy or in Wuhan last year, what if we can transform very quickly the indoor gymnasium to a COVID hospital? So but at that point we didn't need that, but how about more like building this more like a hospital, like a medical center, and then use it for a different purpose. So we thought about this as a home care unit service. Home care service can be combined with this system. So in Korean, 재택치료. So this was a finally kind of made transformed hospital, or more like a hospital. We call it a special treatment center. And this shows how it was built. So actually, we spent about, during the summer, we spent about working hours, about 2 weeks, but we realized that about within a week, we can transform this indoor gym space to more like a hospital function medical center. And this is the kind of scenes that we take a photo before the patients came in. So this is an X-ray center that we can take X-ray outside of the building. So which you can see that there are many corridors and kind of a space outside, just right outside the patient's room. So this was a layout, and we could, depending on the size of the space, we could coordinate this paths of the medical staff and patients, and we can kind of customize without interacting with direct patients. But still, the medical staff can treat face-to-face without touching them. This was revised, customized the monitoring system and also the control units, so that you can control and monitor all the system, the pressure, status, and temperature and humidity, and also whether there is anything wrong or not. We implemented this treatment center last October, September, October, for a month. So at that time, the COVID situation was a bit stabilized, but so the only Gyeonggi-do was very active in home care, so that the COVID patients doesn't come to the hospital. So that we treated about 116 patients, and the system is that usually if the COVID patients are hospitalized, they spend about 10 days in hospital or residential treatment center. But in this case, they usually at home. When they have some kind of symptoms, then they comes in a special treatment center, and then just spend 1 or 2 days. If they gets better, then they come back home. And if they gets worse, then they actually goes to hospital. So this is more like a buffer space that reduce a lot of medical workload in the actual hospital. So in a very worst case, this treatment center can be used as actual hospital too. So but in our testing, so we among 116, about 67%, 66% were pneumonia, diagnosed as a pneumonia, but about 83% just come back home safely, and only 16% went to hospital. So that the medical experts said that this is more proves that this is very effective. So we talked a lot with the director of Ansong Hospital, Gyeonggi-do, Gyeonggi Public Hospital, one of the public hospital, and he was. We worked a lot with this medical experts, and then they also evaluated this is very effective and efficient. And one of the things they liked was this system minimized medical resource in terms of the number of staff, admin staff and medical staff, but also maximize the patient's kind of treatment. So we also had a very positive feedback from patients that they were really satisfied, and they thought that this is much better than they expected. So to kind of reflect on what we've done, at the time that we made these slides, we were facing the fourth peak of the COVID, and that the early outbreak, we had to build a new residential treatment center or COVID hospital, and top level hospital has to have a special beds for critically ill patients. So that there has to be two separate medical system has to be provided for the public. So this gives a lot of burden to public health and government. And gradually, when we know a little bit more about this COVID, that it's merged together, and we gradually end up a lot of COVID patients now at home, and then we only use when they are really critically ill, and there are some essential needs for treatment. But I thought that this more another alternative is that whenever we come across this kind of a new infectious disease outbreak, maybe we have to be ready in all these medical facilities and organizations that have to be respond to the immediate outbreak, so that and also gradually, depending on the situation and so over time, I thought that it would be nice to more like a very flexible response to this infectious disease. So what I think we can do with KARE MCM is we actually tested word function and bed function in Gyeongyang Hospital and also Gyeonggi-do. But also we tested it emergency bed and also hospital special treatment center. So which means that we perhaps this KARE MCM can assist this sort of medical services throughout the life cycle of infectious disease outbreak. So in the future, we are thinking of modifying, reusing some of the facilities in Gyeonggi-do area into a outpatient clinic system, which is planning next year. So to conclude, I introduced a multi-purpose system for the whole life cycle of infectious disease outbreak. Perhaps it could lead to a new paradigm to treat the infectious disease. And also, as a design expert here in industrial design department, I'm very glad that this could be a showcase or example of design-led social problem solving innovation. And also, finally, there are a lot of behind stories about how we could do this agile medical system development together with commercial companies and also the many different part of research. And within design domain also, I had to work a lot with other design experts so that possibly could show some different models of how we can actually do this agile development. So that will conclude my talk. Thank you very much. So there are further information here at the websites and YouTubes, and also, so if you go to websites, there can be kind of more information about this, and there are more videos explaining more about these projects last year and this year. And if you could go to the YouTube channel, there are some more information. And also you can actually do the virtual site visit in this site. It all has a link in MCM website. Thank you very much for your attention.